All right, so our last video here of the kinetics chapter is going to be an actually pretty quick one as we just finish up with really what a catalyst is and what it does. A catalyst simply is our fourth and final way to increase a reaction rate. They don't do it quite like increasing the temperature or increasing surface area. Or increasing the concentration. Catalysts are simply things that physically hold the two reactants in the correct orientation, so there's no more chance needed for a correct orientation collision. This physically holds them in the right spot, and therefore a reaction will take place much easier. Now, what this does on paper is it actually affects the activation energy. So what's going to happen is I'm going to draw a pretty standard reaction coordinate here with our products. I'm sorry, with our reactants up there. With our reactants here and our products down here. And what happens is, on paper, a catalyst simply lowers the activation energy. And I've seen people be asked to draw these before on the AP exam. They give you an uncatalyzed reaction coordinate, which is the one up here, the whole line, and then they said trace on the graph what a catalyzed reaction would look like. And the only thing you need to do is lower the activation energy. Do not touch the starting point of the reactants or the final point of the products. You simply need to draw a lower hill for the activation energy. So now all of a sudden lower energy collisions are capable of producing products, whereas before they obviously would not have been able to overcome the activation energy. So the last thing really from this slide that we need to talk about is what this does in terms of a mechanism. In our mechanism, what we do is we will remove the slowest step of a mechanism of an uncatalyzed reaction, and the mechanism of the catalyzed reaction will have one less step, and it also has eliminated the slowest step. So in a mechanism, what a catalyst does is it simply removes the slowest step. It provides the reaction with another pathway, a quicker pathway to proceed, so that the reaction will occur quicker. And as we talked about in class the other day, identifying catalysts versus intermediates, I'll go through this one more time. Key to understand that intermediates are produced and then consumed, whereas catalysts are backwards. So we have the mechanism that we worked on with the ozone in class the other day, and what we see is, in this case, the chlorine is not an intermediate because it is present from the beginning. In order to be an intermediate, it has to be produced. So here is our intermediate in this. It's been produced and then reconsumed immediately in the next step. So here and here are our intermediates. What makes us a catalyst is if we're there from the beginning and we reform in the very end. So another thing, and the final thing for this chapter to understand, is we will cross out both catalysts and intermediates. Neither of them will show up in the final reaction balanced chemical equation, that is. So catalysts and intermediates are both going to be crossed out. So when you cross something out and then you're asked whether it's a catalyst or an intermediate, then you just have to ask yourself, okay, did we start with it and reform it, or was it produced and then used in a following step?